Question 1. A manufacturing firm, Veridian Dynamics, has recently implemented a comprehensive training program on ecodesign principles as per ISO 14006-2020 guidelines. The training covered life cycle thinking, material selection criteria, energy efficiency in product design, and end-of-life management. To evaluate the effectiveness of this training, which of the following approaches would best demonstrate a tangible impact on the organization's environmental performance and integration of ecodesign into its EMS? Option A. Conducting a follow-up survey with trainees to gauge their perceived understanding of ecodesign concepts and their confidence in applying them. Option B. Assessing the number of new environmental regulations that the company has successfully complied with since the training was delivered. Option C. Analyzing a decrease in the number of nonconformities related to environmental aspects in the product development process, and observing an increase in the documented application of ecodesign tools during design reviews. Option D. Reviewing attendance records for all training sessions and comparing pre- and post-training scores on a general environmental awareness quiz. The correct answer is C. Analyzing a decrease in the number of nonconformities related to environmental aspects in the product development process, and observing an increase in the documented application of ecodesign tools during design reviews. Explanation: ISO 14006-2020 emphasizes the integration of ecodesign principles into an organization's environmental management system, EMS. Evaluating the effectiveness of training provided to personnel on these ecodesign principles requires a systematic approach that goes beyond simple attendance records or post-training quizzes. The standard, while not dictating specific metrics, promotes a results-oriented perspective. To assess if ecodesign training has truly influenced operational practices and product development, an organization should look for tangible evidence of change. This includes observing whether employees are actively applying ecodesign tools and methodologies in their daily work, such as life cycle assessment, LCA, during design phases, selecting environmentally preferable materials, or identifying opportunities for product redesign to reduce environmental impacts. Furthermore, the effectiveness can be gauged by analyzing improvements in key environmental performance indicators, EPI, directly linked to ecodesign efforts, such as reductions in energy consumption, waste generation, or the use of hazardous substances in products. Feedback from employees regarding the practical applicability of the training and its impact on their decision-making processes is also a valuable, though qualitative, component. Ultimately, the most robust evaluation connects the training to demonstrable improvements in the environmental performance of products and processes, aligning with the overarching goals of ISO 14006. Question 2. Consider a global electronics manufacturer aiming to enhance its environmental performance by integrating ecodesign principles, as per ISO 14006-2020. The company produces sophisticated communication devices with complex internal components. To align with evolving environmental regulations, such as the EU's WE and RoHS directives, and to proactively reduce its product lifecycle impacts. Which of the following approaches best exemplifies the integration of ecodesign within their environmental management system? Option A. Focusing solely on optimizing the manufacturing process to reduce waste and energy consumption, assuming that end-of-life management is primarily the responsibility of consumers and waste handlers. Option B. Implementing a take-back program for used devices without altering the product design itself, relying on external recyclers to manage environmental impacts at the end-of-life stage. Option C. Conducting a one-time environmental impact assessment of the current product line and implementing minor material substitutions based on the most stringent available hazardous substance regulations. Option D. Prioritizing material selection for recyclability and reduced hazardous substance content, alongside designing for energy efficiency during the device's operational life and ease of disassembly for end-of-life processing. The correct answer is D. Prioritizing material selection for recyclability and reduced hazardous substance content, alongside designing for energy efficiency during the device's operational life and ease of disassembly for end-of-life processing. Explanation: the core principle of incorporating ecodesign into an environmental management system, as guided by ISO 14006-2020, involves a systematic approach to integrating environmental consideration throughout the product lifecycle. For a company manufacturing complex electronic devices, this means moving beyond end-of-pipe solutions to proactively design for reduced environmental impact from raw material extraction to disposal. This involves understanding and addressing various environmental aspects, including material selection, energy efficiency during use, and recyclability. The Directive on Waste Electrical and Electronic Equipment, WEEE, in the European Union, for instance, mandates specific collection, recycling, and recovery targets, directly influencing design choices for ease of disassembly and material separation. Similarly, regulations concerning hazardous substances, such as the Restriction of Hazardous Substances, RoHS Directive, necessitate careful material substitution. Therefore, a comprehensive ecodesign strategy within an EMS would focus on these regulatory drivers and lifecycle thinking to achieve tangible environmental improvements. The concept of design for environment, DFE, is central here, aiming to minimize environmental burdens at every stage. This involves a holistic view, considering not just the manufacturing process, but also the product's performance during its use phase, e.g., energy consumption, and its end-of-life management. The integration of these considerations ensures that environmental performance is a key design parameter, not an afterthought. Question 3. Consider a manufacturing firm that produces complex electronic devices. To enhance its environmental performance in line with ISO 14006-2020 guidelines, the firm is integrating ecodesign principles into its product development lifecycle. When applying ecodesign within a risk management framework, what is the primary strategic objective for identifying and mitigating potential environmental hazards associated with the product's lifecycle? Option A. Implementing end-of-life recycling programs to manage waste, without necessarily considering the environmental implications of material selection or manufacturing processes. Option B. Strictly adhering to the minimum legal requirements for hazardous waste disposal as mandated by local environmental protection agencies. Option C. Focusing solely on reducing energy consumption during the product's use phase, as this is often the most significant contributor to operational carbon emissions. Option D. Proactively identifying and mitigating potential environmental impacts and hazards throughout the entire product lifecycle by leveraging the organization's environmental management system. The correct answer is D. Proactively identifying and mitigating potential environmental impacts and hazards throughout the entire product lifecycle by leveraging the organization's environmental management system. Explanation. ISO 14006-2020 emphasizes the integration of environmental management into product development, including ecodesign. When considering ecodesign in the context of risk management, the focus shifts to proactively identifying and mitigating potential environmental impacts throughout a product's life cycle. This involves anticipating hazards, such as the release of hazardous substances during manufacturing or disposal, or resource depletion during use. The guideline suggests that an organization's environmental management system, EMS, as defined by ISO 14001, should inform and support ecodesign activities. Therefore, a key aspect of ecodesign risk management is the systematic evaluation of environmental aspects and impacts, which are core components of an EMS. This evaluation helps in understanding where significant environmental risks might arise in the product's life cycle, enabling the implementation of preventative measures during the design phase. For instance, selecting materials with lower embodied energy or designing for disassembly to facilitate recycling are ecodesign strategies directly addressing identified environmental risks. The proactive nature of ecodesign, when linked with risk management principles, aims to prevent pollution and minimize environmental burdens before they occur, aligning with the preventative approach of ISO 14001 and the life cycle perspective of ISO 14006. The integration of ecodesign into the EMS provides a structured framework for this risk mitigation. Question 4. Consider an electronics manufacturer, Innovatech Devices, that is revising its flagship portable communication device. They are evaluating the integration of ecodesign principles as outlined in ISO 14006-2020. Which of the following primary financial outcomes is most directly and consistently achievable through the systematic application of ecodesign for this product, leading to tangible cost reductions across its life cycle? Option A. Increased market share due to a perceived higher environmental value, leading to greater brand loyalty. Option B. Significant reduction in raw material procurement costs and energy consumption during the product's use phase. Option C. Reduced regulatory compliance costs associated with hazardous substance restriction, such as RoHS directives. Option D. Enhanced efficiency in end-of-life processing, resulting in substantial revenue generation from salvaged rare earth elements. The correct answer is B. Significant reduction in raw material procurement costs and energy consumption during the product's use phase. Explanation. The question explores the financial implications of ecodesign, specifically how incorporating environmental considerations into product development can lead to cost savings. ISO 14006-2020 emphasizes that ecodesign is not merely an environmental compliance measure, but a strategic approach that can yield economic benefits. These benefits often stem from reduced material usage, energy efficiency improvements during the product's life cycle manufacturing, use, and end of life, decreased waste generation, and simplified disassembly or recycling processes. For instance, designing a product with fewer components or using lighter, more durable materials can directly lower raw material costs and transportation expenses. Similarly, enhancing energy efficiency in the product's use phase can reduce operational costs for the end user, potentially increasing market appeal, and indirectly, the manufacturer's profitability through higher sales volumes or premium pricing. Furthermore, proactive consideration of end-of-life management, such as designing for easier disassembly and material recovery, can mitigate future disposal costs and even generate revenue from recycled materials. These integrated cost savings, often referred to as green premiums or eco-efficiency gains, are a key driver for adopting ecodesign principles beyond regulatory requirements. The core concept is that environmental performance and economic performance are not mutually exclusive, but can be synergistically enhanced through thoughtful product design and lifecycle management, aligning with the broader goals of sustainable business practices. Question 5. A multinational electronics manufacturer, Lumina Tech, is seeking to leverage its ISO 14006-2020 compliant ecodesign framework to gain a significant market edge. Considering the evolving regulatory landscape, including directives like the EU's ecodesign directive, which mandates energy efficiency and material recyclability for various product categories, and increasing consumer demand for sustainable products, which of the following strategies would most effectively translate their ecodesign integration into a demonstrable competitive advantage? Option A. Investing heavily in advanced pollution control technologies for manufacturing facilities, separate from the product's inherent design, and promoting this as their primary environmental initiative. Option B. Proactively redesigning product lines to exceed upcoming regulatory requirements for material circularity and energy consumption, and actively marketing these advancements to highlight reduced life cycle environmental impact and long-term cost savings for consumers. Option C. Implementing a reactive approach to ecodesign, making changes only when specific environmental regulations are enforced, and primarily communicating compliance rather than innovation. Option D. Focusing solely on internal cost reductions achieved through minor material substitutions in product components, without significant external communication about their ecodesign efforts. The correct answer is B. Proactively redesigning product lines to exceed upcoming regulatory requirements for material circularity and energy consumption, and actively marketing these advancements to highlight reduced life cycle environmental impact and long-term cost savings for consumers. Explanation. ISO 14006-2020 emphasizes the integration of environmental management into product development, particularly through ecodesign principles, to achieve competitive advantage. This advantage stems from various factors, including enhanced brand reputation, reduced operational costs through resource efficiency, compliance with evolving environmental regulations such as the EU's ecodesign directive, Directive 2009/125/EC, and its subsequent regulations, and innovation leading to new market opportunities. Organizations that proactively incorporate ecodesign are better positioned to anticipate future regulatory changes and consumer preferences for sustainable products. This forward-thinking approach can differentiate them from competitors, attract environmentally conscious customers, and foster stronger stakeholder relationships. The guidelines suggest that by systematically considering the environmental aspects of a product throughout its life cycle, from raw material extraction to end-of-life management, businesses can identify opportunities for improvement that also yield economic benefits. This can include material substitution, energy efficiency improvements, and design for disassembly, all contributing to a more resilient and sustainable business model. The key is to view environmental performance not just as a compliance issue, but as a strategic driver for business growth and market leadership. Question 6. A manufacturing firm specializing in domestic appliances is seeking to enhance its environmental performance in line with ISO 14006-2020. Their latest product line includes advanced refrigerators. Considering the directive establishing a framework for the ecodesign of energy-related products, which ecodesign requirement, when integrated into their environmental management system, most effectively address the significant environmental aspect of energy consumption during the use phase of these refrigerators. Option A. Prioritizing the use of recycled materials in the casing and internal components, even if it slightly increases manufacturing energy. Option B. Implementing a take-back program for end-of-life products without altering the product's energy performance during its operational life. Option C. Focusing solely on reducing packaging materials, assuming the primary environmental impact is during transportation. Option D. Designing for enhanced thermal insulation and optimizing the refrigerant system for maximum energy efficiency during operation. The correct answer is A. Prioritizing the use of recycled materials in the casing and internal components, even if it slightly increases manufacturing energy. Explanation. ISO 14006-2020 emphasizes the integration of ecodesign principles throughout the product lifecycle. For energy-related products, this often involves addressing energy consumption during the use phase, which is a significant environmental aspect. Directive 2009/125/EC of the European Parliament and of the Council, establishing a framework for the ecodesign of energy-related products, provides a regulatory context. This directive mandates that manufacturers consider the entire life cycle environmental impacts of their products, with a strong focus on energy efficiency. Incorporating ecodesign requirements under ISO 14006 involves systematically identifying and evaluating environmental aspects, including energy use, and implementing measures to reduce them. This can involve design choices that improve energy performance, the selection of materials with lower embodied energy, or designing for easier repair and recycling to minimize waste and resource depletion. The standard guides organizations to embed these considerations into their environmental management systems, ensuring that ecodesign is not an afterthought but a core part of product development and improvement processes, aligning with broader sustainability goals and regulatory compliance. Question 7. A manufacturing firm aiming to align its operations with ISO 14006-2020 guidelines and leverage environmental performance for market advantage is evaluating how to integrate ecodesign into its overarching business strategy. Considering the directive's emphasis on life cycle thinking and the broader goal of sustainable business, which of the following approaches best represents a strategic integration of ecodesign principles within the company's core business model, moving beyond basic regulatory adherence? Option A. Primarily focusing on meeting the minimum environmental standards mandated by regulations such as the EU's ecodesign directive and local waste management laws, with ecodesign efforts being reactive to compliance requirements. Option B. Investing in end-of-life product take-back schemes and recycling programs as the primary ecodesign strategy, without a comprehensive assessment of upstream environmental impacts during material sourcing or manufacturing. Option C. Proactively redesigning products and processes to minimize environmental impacts across their entire life cycle, viewing ecodesign as a catalyst for innovation, cost reduction through resource efficiency, and enhanced market positioning. Option D. Implementing ecodesign solely within the research and development department as a specialized function, without significant cross-functional integration into marketing, supply chain, or overall corporate planning. The correct answer is C. proactively redesigning products and processes to minimize environmental impacts across their entire life cycle, viewing ecodesign as a catalyst for innovation, cost reduction through resource efficiency, and enhanced market positioning. Explanation: ISO 14006 2020 emphasizes the integration of ecodesign principles into an organization's environmental management system, EMS, to achieve life cycle thinking and continuous improvement. When considering ecodesign as a core component of business strategy, it moves beyond mere compliance with regulations like the EU's Ecodesign Directive, Directive 2009/125/EC, or national waste reduction mandates. Instead, it involves proactively identifying and leveraging environmental aspects throughout the product or service lifecycle to create competitive advantage. This strategic integration means that ecodesign considerations are not an afterthought, but are embedded in research and development, marketing, supply chain management, and even corporate social responsibility reporting. A key aspect of this strategic alignment is the recognition that environmental performance can drive innovation, reduce operational costs through resource efficiency, enhance brand reputation, and open new market opportunities. Therefore, an organization that strategically incorporates ecodesign would view it as a driver for sustainable business growth, influencing product design, material selection, manufacturing processes, and end-of-life management to minimize environmental impact while maximizing value creation. This holistic approach ensures that environmental considerations are a source of innovation and competitive differentiation, rather than solely a cost of compliance. Question 8. Consider a manufacturing firm aiming to embed circular economy principles into its product development lifecycle, guided by ISO 14006/2020, which specific ecodesign strategy, directly supported by the standards guidelines for incorporating environmental management into design, would most effectively facilitate the transition from a linear take-make-dispose model to a circular one for their electronic devices. Option A. Designing for disassembly and modularity to enable efficient repair, refurbishment, and material recovery at end of life. Option B. Focusing solely on reducing the energy consumption of the product during its operational use phase. Option C. Developing comprehensive marketing materials that highlight the product's perceived durability to consumers. Option D. Implementing a robust quality control system to minimize immediate product failures during the initial use phase. The correct answer is A. Designing for disassembly and modularity to enable efficient repair, refurbishment, and material recovery at end of life. Explanation: ISO 14006/2020 emphasizes integrating environmental considerations into the design process, which aligns with circular economy principles. Specifically, the standard guides organizations in developing an environmental management system, EMS, that supports ecodesign. Ecodesign aims to reduce environmental impacts throughout a product's life cycle, from raw material extraction to end-of-life management. Circular economy strategies, such as designing for durability, repairability, remanufacturing, and recyclability, are direct applications of ecodesign principles. The standard promotes a systematic approach to identifying and managing environmental aspects, including those related to material selection, energy efficiency, and waste reduction during the design phase. This proactive integration of environmental performance into product development is crucial for achieving the goals of both ecodesign and the circular economy, ultimately contributing to sustainable consumption and production patterns. The standard's focus on lifecycle thinking ensures that all potential environmental burdens are considered, facilitating the transition towards closed-loop systems where resources are kept in use for as long as possible. Question 9. A mid-sized electronics manufacturer committed to ISO 14006/2020 principles observes a global trend towards stricter legislation mandating extended producer responsibility (EPR) and greater emphasis on product circularity, including requirements for easier disassembly and higher recycled content. Considering this evolving regulatory landscape, which of the following actions would represent the most strategically aligned response for the company to proactively integrate these anticipated changes into its environmental management system and ecodesign framework? Option A. Invest in research and development for alternative, less hazardous materials to substitute existing components, aiming to meet potential future substance restrictions. Option B. Revise the company's ecodesign policy to explicitly include design for disassembly, repairability, and recyclability, alongside a commitment to increasing the use of recycled materials in new product lines. Option C. Establish a dedicated waste management department to handle the collection and proper disposal of end-of-life products, ensuring compliance with current waste legislation. Option D. Focus on ensuring current product designs meet all existing national and international environmental compliance standards, such as RoHS and WE directives, through rigorous testing and documentation. The correct answer is B. Revise the company's ecodesign policy to explicitly include design for disassembly, repairability, and recyclability, alongside a commitment to increasing the use of recycled materials in new product lines. Explanation. The question asks to identify the most strategic response for a manufacturing firm to evolving environmental regulations concerning product end-of-life management, specifically in the context of ISO 14006-2020 guidelines for ecodesign. ISO 14006-2020 emphasizes integrating environmental considerations into product design and development processes to prevent pollution and improve environmental performance throughout the product lifecycle. Evolving regulations, such as extended producer responsibility, EPR schemes, and restrictions on hazardous substances, like RoHS directives or similar national legislations, directly impact product design, material selection, and end-of-life treatment. A proactive approach that anticipates these changes and incorporates them into the ecodesign strategy is crucial. Option A directly addresses this by focusing on updating the ecodesign policy to include provisions for designing products with enhanced recyclability and disassembly, which aligns with anticipated regulatory shifts and the core principles of ISO 14006. This proactive stance ensures compliance and can lead to competitive advantages by reducing future compliance costs and improving resource efficiency. Option B is less strategic as it focuses solely on reactive compliance with current laws, missing the forward-looking aspect of ecodesign. Option C is also reactive, addressing only the immediate disposal phase without integrating it into the design process as advocated by ISO 14006. Option D is too narrow, focusing only on material substitution without encompassing the broader design and end-of-life considerations that evolving regulations often mandate. Therefore, the most effective strategy is to proactively adapt the ecodesign policy to anticipate and incorporate future regulatory requirements related to product lifecycle management. Question 10. Considering the principles outlined in ISO 14006-2020 for incorporating ecodesign into environmental management systems, which strategic focus within the product development lifecycle would most significantly enhance resource efficiency, particularly in light of evolving regulatory landscapes like the EU's Circular Economy Action Plan? Option A. Prioritizing the selection of materials with high recycled content and designing for ease of disassembly and material recovery at end of life. Option B. Investing in advanced energy-efficient manufacturing equipment to reduce operational energy consumption during production. Option C. Developing comprehensive product labeling to inform consumers about proper disposal methods for extended product lifespan. Option D. Implementing stringent quality control measures for incoming raw materials to minimize immediate production waste. The correct answer is A. Prioritizing the selection of materials with high recycled content and designing for ease of disassembly and material recovery at end of life. Explanation. ISO 14006-2020 emphasizes the integration of environmental considerations into the product development process, particularly through ecodesign principles. Resource efficiency, a core tenet of ecodesign, involves minimizing the use of raw materials, energy, and water throughout the product's life cycle. This aligns with broader environmental management system goals and can be influenced by regulatory frameworks such as the EU's ecodesign directive, Directive 2009/125/EC, which sets requirements for energy-related products to improve their environmental performance. The question probes the understanding of how ecodesign, as guided by ISO 14006-2020, specifically addresses resource efficiency by focusing on material selection and end-of-life management, prioritizing the use of recycled or renewable materials and designing for disassembly and recyclability are key strategies to reduce the environmental burden associated with resource depletion and waste generation. This proactive approach contributes to a circular economy model, which is increasingly being supported by legislation and market demand. Therefore, the most effective strategy for enhancing resource efficiency within an ecodesign framework, as per ISO 14006-2020, is to focus on the intrinsic material properties and the product's fate after its intended use. Question 11. Considering the evolving landscape of product stewardship and the proactive integration of ecodesign principles within environmental management systems, as guided by ISO 14006-2020, which strategic approach best anticipates future trends in minimizing product lifecycle environmental impacts, particularly in light of emerging circular economy models and digital traceability requirements? Option A. Focusing solely on enhancing energy efficiency during the use phase of products, as this is often the most significant environmental impact during a product's operational life, and ensuring compliance with current energy performance standards. Option B. Conducting periodic environmental impact assessments for new product introductions, with a primary objective of meeting minimum legal requirements and avoiding environmental fines. Option C. Implementing a comprehensive waste management strategy that emphasizes recycling and proper disposal of all product components at the end of their life, thereby fulfilling regulatory obligations for waste reduction. Option D. Prioritizing the development and implementation of digital product passports linked to material passports, facilitating granular end-of-life material recovery and reuse within a closed-loop system, alongside a robust life cycle assessment (LCA) framework that informs design choices from raw material sourcing to disposal. The correct answer is D. Prioritizing the development and implementation of digital product passports linked to material passports, facilitating granular end-of-life material recovery and reuse within a closed-loop system, alongside a robust life cycle assessment (LCA) framework that informs design choices from raw material sourcing to disposal. Explanation: ISO 14006-2020 emphasizes a life cycle perspective for environmental management and product design. This involves considering environmental aspects from raw material extraction through to end-of-life management. The standard encourages organizations to integrate ecodesign principles into their environmental management system, EMS, to reduce environmental impacts throughout the product's life cycle. This integration is not merely about compliance with regulations like the EU's Ecodesign Directive, Directive 2009/125/EC, or REACH, Regulation EC, No. 1907/2006, but about proactively improving environmental performance. Future trends in ecodesign, as anticipated by ISO 14006-2020, involve a deeper integration of circular economy principles, digital product passports, and enhanced supply chain transparency to facilitate more sustainable material flows and product lifespans. The standard promotes a systematic approach, aligning ecodesign with the Plan Do Check Act (PDCA) cycle inherent in ISO 14001. This means establishing clear ecodesign policies, planning for environmental improvements, implementing design changes, checking their effectiveness through performance evaluation, and acting to continually improve. The focus is on enabling organizations to make informed decisions that minimize environmental burdens at all stages, moving beyond simple end-of-pipe solutions to preventative design strategies. Question 12. When a company is developing an ecodesign strategy for a new line of portable audio players, according to ISO 14006-2020 guidelines, which of the following represents a crucial consideration for identifying environmental aspects and their associated impacts across the entire product lifecycle? Option A. Primarily focusing on the energy consumption during the playback of music, as this is the most direct user interaction with the product. Option B. Evaluating the potential for microplastic shedding from the device's casing during normal use and its subsequent environmental dispersion. Option C. Assessing the embodied energy and resource depletion associated with the extraction and processing of rare earth elements used in the internal circuitry and the potential for hazardous waste generation during disposal. Option D. Investigating the impact of packaging materials on local landfill capacity and the recyclability of the cardboard used in the outer box. The correct answer is A. Primarily focusing on the energy consumption during the playback of music, as this is the most direct user interaction with the product. Explanation: ISO 14006 2020 emphasizes the integration of ecodesign principles throughout the product lifecycle. Identifying and evaluating environmental aspects and their corresponding impacts is a foundational step in this process. An environmental aspect is an element of an organization's activities, products, or services that can interact with the environment. An environmental impact is any change to the environment, whether adverse or beneficial, wholly or partially resulting from an organization's environmental aspects. When considering the ecodesign of a new electronic device, a manufacturer must look beyond just the manufacturing phase. For instance, the energy consumed during the use phase of a laptop is a significant environmental aspect, leading to impacts such as greenhouse gas emissions from electricity generation. Similarly, the disposal of the device at the end of its life, potentially releasing hazardous substances into landfills, represents another critical aspect and impact. The selection of raw materials, the manufacturing processes, the packaging, the transportation, the use phase, and the end-of-life treatment all contribute to the overall environmental footprint. The standard guides organizations to systematically identify these aspects and assess their potential impacts, prioritizing those that are significant for ecodesign improvements. This proactive approach allows for the incorporation of environmental considerations early in the design stage, aiming to prevent pollution and minimize resource depletion across the entire life cycle. Question 13. An organization implementing ISO 14006 2020 is undergoing an internal audit of its ecodesign integration. The audit team is reviewing the process by which ecodesign measures are assessed for their continued effectiveness and compliance with evolving environmental legislation, such as the EU's ecodesign directive and related directives like RoHS. Which of the following audit findings would most strongly indicate a deficiency in the organization's ecodesign review process concerning regulatory alignment? Option A. The organization's internal audit schedule for ecodesign processes is determined by product launch timelines rather than a risk-based approach. Option B. The audit team found that the ecodesign team primarily focuses on material selection and energy consumption during product development, neglecting other lifecycle stages. Option C. The review process for ecodesign measures does not systematically incorporate updates to environmental legislation or technological advancements that could impact product compliance or performance. Option D. The ecodesign review meetings are documented, but the minutes do not always detail specific decisions made regarding design modifications. The correct answer is C. The review process for ecodesign measures does not systematically incorporate updates to environmental legislation or technological advancements that could impact product compliance or performance. Explanation: ISO 14006 2020 emphasizes the integration of ecodesign principles into an environmental management system, EMS. When auditing an organization's ecodesign process, particularly concerning its alignment with regulatory frameworks like the EU's Ecodesign Directive 2009/125/EC, auditors need to verify that the organization's internal procedures effectively capture and address ecodesign requirements throughout the product lifecycle. A critical aspect of this verification involves assessing whether the organization's review process for ecodesign measures considers the dynamic nature of environmental legislation and technological advancements. This includes evaluating if the review mechanism proactively identifies potential noncompliance with current or upcoming regulations, such as those pertaining to energy efficiency, material restrictions, e.g., RoHS directive, or product durability. The effectiveness of an ecodesign audit hinges on its ability to confirm that the organization's management system drives continuous improvement in environmental performance by anticipating and responding to these external drivers. Therefore, the audit should focus on the systematic identification and incorporation of updated legal requirements and best practices into the ecodesign decision-making process, ensuring that the organization's EMS remains robust and compliant. Question 14. A manufacturing firm specializing in consumer electronics is seeking to align its product development strategy with the principles outlined in ISO 14006-2020, aiming to enhance its environmental performance beyond basic regulatory compliance such as the EU's Energy-Related Products (ERP) directive. They are particularly interested in embedding ecodesign principles to foster sustainable development. Which of the following strategic orientations would most effectively integrate environmental considerations throughout the entire product lifecycle, aligning with the proactive and holistic approach recommended by the standard? Option A. Concentrating efforts on reducing packaging waste and ensuring compliance with substance restrictions like REACH registration, evaluation, authorization, and restriction of chemicals, without a comprehensive life cycle perspective. Option B. Prioritizing the use of recycled materials and designing for disassembly and recyclability at the end-of-life stage, while also evaluating energy efficiency during the product's use phase and minimizing the environmental impact of raw material sourcing. Option C. Focusing primarily on meeting the minimum energy efficiency standards set by national regulations and conducting a one-time environmental impact assessment at the design stage for new product lines. Option D. Implementing a post-production waste management program to handle product returns and investing in end-of-pipe pollution control technologies for manufacturing facilities. The correct answer is B. Prioritizing the use of recycled materials and designing for disassembly and recyclability at the end-of-life stage, while also evaluating energy efficiency during the product's use phase and minimizing the environmental impact of raw material sourcing. Explanation: the core principle of ecodesign, as guided by ISO 14006-2020, is the integration of environmental considerations throughout the entire product lifecycle. This involves proactively identifying and mitigating potential environmental impacts from the earliest stages of design to the end-of-life management. The standard emphasizes a systematic approach, moving beyond mere compliance with regulations like the EU's ecodesign directive, Directive 2009/125/EC, or specific substance restrictions such as RoHS, restriction of hazardous substances. Instead, it advocates for a holistic view that considers resource efficiency, material selection, energy consumption during use, and recyclability or biodegradability. The goal is to achieve a reduction in environmental burden across all life cycle stages. This proactive integration ensures that environmental performance is a design parameter, not an afterthought, leading to more sustainable products and processes. Considering the entire life cycle, from raw material extraction to disposal, is fundamental to achieving true environmental improvements and fostering sustainable development. Question 15. Consider an organization that has integrated ecodesign principles into its EMS, aligning with ISO 14006-2020. The organization manufactures electronic components and is subject to regulations such as the Restriction of Hazardous Substances (RoHS) directive. To assess the effectiveness of its ecodesign system, which of the following evaluation approaches would most comprehensively demonstrate the system's contribution to achieving environmental objectives and demonstrating compliance beyond mere regulatory adherence? Option A. An analysis of the reduction in packaging waste generated during product distribution, supported by a review of internal audit findings related to ecodesign implementation procedures. Option B. A report detailing the number of products that meet the minimum requirements of the RoHS directive and a qualitative assessment of employee awareness regarding ecodesign principles. Option C. A comprehensive review of life cycle assessment (LCA) data demonstrating significant reductions in embodied energy and material intensity across key product lines, coupled with documented evidence of ecodesign criteria influencing at least 80% of new product development decisions, and proactive supplier engagement on substance restrictions beyond RoHS. Option D. A compilation of customer feedback surveys that mention the environmental attributes of products, alongside a summary of the organization's participation in industry-wide sustainability forums. The correct answer is C. A comprehensive review of life cycle assessment (LCA) data demonstrating significant reductions in embodied energy and material intensity across key product lines, coupled with documented evidence of ecodesign criteria influencing at least 80% of new product development decisions, and proactive supplier engagement on substance restrictions beyond RoHS. Explanation: ISO 14006-2020 emphasizes the integration of ecodesign into an organization's environmental management system, EMS, to systematically reduce environmental impacts throughout a product's life cycle. Evaluating the effectiveness of such an integrated system requires looking beyond simple compliance with regulations like the EU's ecodesign directive, Directive 2009/125/EC, or national waste management laws. The standard suggests a holistic approach to assessment. Key performance indicators, KPI, should reflect the actual reduction in environmental burdens, such as decreases in energy consumption during use, material efficiency improvements, or reductions in hazardous substances. It also involves assessing the extent to which ecodesign principles are embedded in decision-making processes, from initial concept to end-of-life management. This includes the maturity of life cycle assessment, LCA, integration, the effectiveness of supplier engagement on ecodesign requirements, and the demonstrable improvement in product environmental performance compared to baseline or previous versions. A robust evaluation would also consider the alignment of ecodesign objectives with broader business strategy and the organization's ability to adapt to evolving environmental legislation and market expectations. The success is measured by quantifiable environmental improvements and the systemic integration of ecodesign thinking. Question 16. A manufacturing firm specializing in consumer electronics is seeking to enhance its environmental performance by systematically incorporating ecodesign principles into its product development lifecycle, as guided by ISO 14006-2020. Considering the standard's emphasis on integration with the existing environmental management system, EMS, which of the following actions would most effectively embed ecodesign into the organization's core operational processes? Option A: relying solely on compliance with external environmental regulations, such as the EU's ecodesign directive, without internal process integration. Option B: proactively embedding ecodesign criteria and impact assessment methodologies into the initial conceptualization and design phases of new product development. Option C: developing a separate, standalone ecodesign policy that is distinct from the organization's overarching environmental policy. Option D: conducting post-production environmental audits to identify potential areas for ecodesign improvement in future product iterations. The correct answer is B: proactively embedding ecodesign criteria and impact assessment methodologies into the initial conceptualization and design phases of new product development. Explanation: ISO 14006-2020 emphasizes the integration of ecodesign into an organization's existing environmental management system, EMS. This integration aims to systematically embed environmental considerations throughout the product lifecycle, from conception to end of life. Clause 5.2.1 of the standard, integration of ecodesign into the environmental management system, outlines the necessity of aligning ecodesign activities with the overall EMS framework. This involves ensuring that ecodesign objectives are consistent with the organization's environmental policy, and that ecodesign processes are incorporated into relevant management system processes, such as design and development, purchasing, and production. The standard suggests that this integration can be achieved by adapting existing procedures or creating new ones that explicitly address ecodesign. It also highlights the importance of considering relevant legal requirements and other applicable environmental aspects throughout the product lifecycle. Therefore, the most effective way to ensure successful integration, as per the guidelines, is to proactively incorporate ecodesign principles and practices into the established design and development phases of the product lifecycle, ensuring that environmental performance is a key consideration from the outset, rather than an afterthought. This approach directly supports the systematic embedding of ecodesign throughout the organization's operations and product development cycles, aligning with the core intent of ISO 14006-2020. Question 17. A company is developing a new portable music player and aims to significantly reduce its overall carbon footprint, aligning with the principles of ISO 14006-2020. They are evaluating different ecodesign strategies. Which of the following strategies would most effectively contribute to achieving this objective, considering both embodied and operational carbon emissions, and potential regulatory alignment. Option A. Prioritizing the use of recycled rare earth elements in the battery, designing for enhanced energy efficiency during playback, and ensuring the device is easily disassembled for component repair and eventual material recovery. Option B. Focusing solely on reducing the manufacturing energy intensity of the device's casing by using a novel bioplastic and implementing a robust packaging recycling program. Option C. Developing a proprietary charging technology that reduces charging time by 20% and marketing the device with a focus on its extended warranty period. Option D. Investing in carbon offsetting programs for the manufacturing process and encouraging consumers to use the device sparingly to conserve energy. The correct answer is A. Prioritizing the use of recycled rare earth elements in the battery, designing for enhanced energy efficiency during playback, and ensuring the device is easily disassembled for component repair and eventual material recovery. Explanation: ISO 14006-2020 emphasizes integrating environmental considerations into the product development process, including ecodesign. Reducing a product's carbon footprint throughout its life cycle is a key objective. Life cycle assessment, LCA, is a crucial tool for identifying environmental impacts, including greenhouse gas emissions. When considering a new electronic device, a comprehensive ecodesign strategy would prioritize materials with lower embodied carbon, designed for energy efficiency during use, and facilitate end-of-life recycling. For instance, if a new device uses recycled aluminum, lower embodied energy than primary aluminum, and has an energy-saving mode that reduces its operational carbon emissions by 15% compared to the previous model, these are direct contributions to footprint reduction. Furthermore, designing for modularity to enable easier repair and component upgrades extends the product's useful life, directly reducing the need for new manufacturing and its associated emissions. Regulations like the EU's ecodesign Directive, Directive 2009/125/EC, and related energy labeling requirements provide a framework for setting minimum performance standards and encouraging manufacturers to improve energy efficiency, which directly impacts the operational carbon footprint. Therefore, a holistic ecodesign approach, informed by LCA and aligned with regulatory drivers, is essential for minimizing the carbon footprint of products. Question 18. Consider an advanced manufacturing firm aiming to leverage ecodesign principles, as outlined in ISO 14006-2020, to gain a significant competitive edge. Beyond meeting the minimum requirements of environmental legislation, such as the EU's ecodesign Directive or substance restrictions like RoHS, which strategic approach would most effectively translate ecodesign integration into sustainable competitive advantage? Option A. Proactively identifying and capitalizing on opportunities for product innovation that reduce lifecycle environmental impacts, enhance product performance, and appeal to environmentally conscious market segments. Option B. Implementing ecodesign solely as a reactive measure to address emerging consumer complaints about environmental impacts. Option C. Focusing solely on achieving compliance with current environmental regulations to avoid penalties and maintain market access. Option D. Prioritizing cost reduction by substituting materials without a thorough assessment of their life cycle environmental implications or market reception. The correct answer is A. Proactively identifying and capitalizing on opportunities for product innovation that reduce life cycle environmental impacts, enhance product performance, and appeal to environmentally conscious market segments. Explanation: the core of achieving competitive advantage through ecodesign, as guided by ISO 14006-2020, lies in proactively integrating environmental consideration throughout the product lifecycle. This integration goes beyond mere compliance with regulations like the EU's ecodesign Directive, Directive 2009/125/EC, or specific substance restriction, such as those found in RoHS, restriction of hazardous substances. Instead, it involves a strategic shift to identify and leverage opportunities for innovation that reduce environmental impact while simultaneously enhancing product value and market appeal. This can manifest as developing products with extended durability, modular designs for easier repair and upgrades, or utilizing recycled and renewable materials that can also lead to cost savings and unique branding. By anticipating future environmental legislation and consumer preferences for sustainable products, organizations can position themselves as leaders, differentiate their offerings from competitors, and potentially access new markets or customer segments that prioritize environmental performance. The ultimate goal is to transform environmental responsibility into a source of genuine business value and market differentiation, rather than viewing it solely as a cost or constraint. Question 19. Consider a multinational corporation specializing in the production of complex, high-performance computing hardware. This industry is characterized by rapid technological advancement, significant material intensity, and evolving global environmental regulations, such as the EU's RoHS and WE directives, which mandate the restriction of certain hazardous substances and the responsible management of electronic waste. To effectively incorporate ecodesign principles as outlined in ISO 14006-2020, which of the following strategies would most comprehensively address the lifecycle environmental impacts of their products, particularly in anticipation of future regulatory trends and market demands for circularity? Option A. Implementing a comprehensive post-consumer recycling program for all returned electronic waste, ensuring that collected materials are processed according to best available techniques. Option B. Focusing exclusively on optimizing the energy efficiency of the manufacturing processes to reduce operational emissions and waste generation within the production facilities. Option C. Prioritizing the selection of materials with inherently lower environmental impact and greater recyclability during the initial design and prototyping phases, even if it entails a moderate increase in upfront component costs. Option D. Conducting detailed lifecycle assessments, LCA, for each product line and publishing the findings annually to inform stakeholders about environmental performance. The correct answer is C. Prioritizing the selection of materials with inherently lower environmental impact and greater recyclability during the initial design and prototyping phases, even if it entails a moderate increase in upfront component costs. Explanation. The core of ISO 14006-2020 is the integration of environmental considerations into product development and management throughout its lifecycle. For company manufacturing advanced electronic components, which are subject to stringent regulations like the EU's restriction of hazardous substances, RoHS, directive, and the Waste Electrical and Electronic Equipment, WE, directive, the ecodesign process must be deeply embedded. This involves a systematic approach to minimize environmental impacts at each stage, from material selection and manufacturing processes to product use and end-of-life management. Focusing on the design phase is paramount because it influences over 80% of a product's environmental impacts. Therefore, a key ecodesign strategy for such a company would be to proactively select materials with lower inherent toxicity and higher recyclability, even if initial costs are slightly higher, to ensure compliance with current and future regulations, and to facilitate easier end-of-life processing. This proactive material selection directly addresses the life cycle thinking emphasized in ISO 14006. It also aligns with the directives aimed to reduce the environmental footprint of electronics, anticipating potential future restrictions on certain substances, and preparing for increased demands for product circularity. The other options represent less effective or incomplete approaches. Simply conducting life cycle assessments without integrating findings into design decisions is insufficient. Focusing solely on end-of-life management neglects the significant impact of upstream design choices. While improving manufacturing efficiency is important, it does not address the fundamental material choices that have a profound life cycle effect and are directly controllable during the ecodesign phase. Question 20. When creating design for environment, DFE checklists for a company manufacturing advanced solar charging power banks, which of the following checklist elements would most directly align with the life cycle thinking and pollution prevention principles espoused in ISO 14006-2020, considering potential regulatory frameworks like the EU's ecodesign directive? Option A. Ensuring the packaging meets aesthetic quality standards and includes detailed marketing information about the product's features. Option B. Verifying that the product's warranty period is competitive with market offerings and that customer support channels are readily available. Option C. confirming that the product's internal components are sourced from suppliers with ISO 9001 certification and that assembly processes are streamlined for speed. Option D. Evaluating the potential for incorporating user-repairable modules and prioritizing materials with high recycled content and low embodied energy. The correct answer is D. Evaluating the potential for incorporating user-repairable modules and prioritizing materials with high recycled content and low embodied energy. Explanation: ISO 14006-2020 emphasizes the integration of ecodesign principles throughout the product lifecycle. When developing design for environment, DFE, checklists for a new line of portable electronic devices, key consideration is to ensure these checklists effectively guide designers toward minimizing environmental impacts. The standard suggests that ecodesign should address various lifecycle stages, including material selection, manufacturing, use, and end of life. A comprehensive DFE checklist, aligned with ISO 14006-2020, would therefore focus on actionable items that directly contribute to reducing environmental burdens. For instance, assessing the recyclability of components, the energy efficiency during the use phase, and the potential for disassembly are crucial. Regulatory compliance, such as adherence to directives like the Restriction of Hazardous Substances, RoHS, and the Waste Electrical and Electronic Equipment, WEEE, directive, must also be integrated. A checklist that prioritizes material substitution with less hazardous or more sustainable alternatives, promotes modular design for easier repair and upgrades, and mandates the use of recycled content would be highly effective. The effectiveness of a DFE checklist is measured by its ability to drive tangible improvements in environmental performance across the product's lifecycle, moving beyond mere compliance to proactive environmental stewardship in design. The core of ecodesign, as guided by ISO 14006-2020, is about preventing pollution at the source through design choices. Therefore, a checklist should prompt questions that lead to such preventative actions. Question 21. When evaluating the effectiveness of ecodesign initiatives aimed at reducing the environmental footprint of a new range of portable audio devices, which of the following approaches best aligns with the principles of ISO 14006-2020 for performance measurement and continuous improvement? Option A. Focusing exclusively on the reduction of manufacturing waste generated during the production phase, neglecting other lifecycle stages like product use and disposal. Option B. Conducting periodic customer satisfaction surveys to gauge perceptions of the device's environmental friendliness without directly measuring specific environmental impacts. Option C. Establishing lifecycle assessment, LCA, benchmarks for comparable devices and tracking key environmental performance indicators, EPI, related to material selection, energy consumption during use, and end-of-life recyclability, comparing these against the established benchmarks and previous product generations. Option D. Relying solely on compliance with national environmental regulations for electronic waste disposal, assuming this adequately covers all ecodesign performance aspects. Correct answer is C. Establishing lifecycle assessment, LCA, benchmarks for comparable devices and tracking key environmental performance indicators, EPI, related to material selection, energy consumption during use, and end-of-life recyclability, comparing these against the established benchmarks and previous product generations. Explanation: ISO 14006-2020 emphasizes the integration of environmental considerations into the design process, often referred to as ecodesign. Performance measurement in this context involves evaluating the environmental performance of products and services throughout their lifecycle, from raw material extraction to end-of-life disposal. The standard advocates for a systematic approach to identify, measure, and monitor key environmental performance indicators, EPI, that are relevant to the organization's environmental policy and objectives, as well as the specific ecodesign strategy. This measurement should not be a one-time event, but an ongoing process to drive continuous improvement. It involves setting baseline data, establishing targets, and tracking progress. The effectiveness of ecodesign measures is assessed by comparing the environmental performance of redesigned products or services against previous versions or benchmarks. For instance, if an organization aims to reduce energy consumption in its electronic devices, a relevant EPI would be the energy consumed per functional unit during the use phase. Measuring this EPI before and after implementing ecodesign changes, such as using more energy-efficient components or optimizing software, would demonstrate the impact of the ecodesign efforts. This data then informs future design decisions and helps in meeting regulatory requirements, such as those related to energy efficiency standards or material restrictions. The focus is on quantifiable improvements and demonstrating tangible environmental benefits, which are then communicated through the environmental management system. Question 22. A multinational electronics manufacturer striving to incorporate ecodesign principles as outlined in ISO 14006-2020 is developing a new line of portable audio devices. During the material selection phase, the procurement team identifies a key component that can be sourced from a supplier known for its competitive pricing, but also for documented instances of inadequate worker safety protocols and potentially exploitative labor practices, which may contravene national labor regulations in the supplier's country of operation. Given the organization's commitment to both environmental performance and broader corporate social responsibility, which of the following actions best reflects the integration of ecodesign guidelines from ISO 14006-2020 with social considerations? Option A. Seek an alternative supplier for the component that offers the lowest environmental footprint, irrespective of their social or labor practices, to maximize the product's environmental credentials as per the standard. Option B. Prioritize sourcing from suppliers who demonstrate compliance with environmental regulations and ethical labor practices, even if it incurs a slightly higher material cost, to ensure a responsible supply chain that aligns with the holistic intent of ecodesign. Option C. Proceed with the lower-cost supplier, focusing solely on the product's environmental impact during its use phase and end of life, as ISO 14006-2020 primarily addresses environmental aspects. Option D. Engage in a one-time audit of the identified supplier to verify their environmental claims, without explicitly addressing the reported labor concerns, assuming they do not directly impact environmental performance. The correct answer is B. Prioritize sourcing from suppliers who demonstrate compliance with environmental regulations and ethical labor practices, even if it incurs a slightly higher material cost, to ensure a responsible supply chain that aligns with the holistic intent of ecodesign. Explanation. ISO 14006-2020 emphasizes integrating environmental considerations into product development, which inherently touches upon broader sustainability aspects, including social responsibility. While the standard's primary focus is environmental management systems and ecodesign, its implementation often necessitates considering the social implications of product life cycles. This includes how a product's design and manufacturing processes might affect the well-being of workers, communities, and end users. For instance, the selection of materials, energy consumption during use, and end-of-life disposal methods can all have social consequences. Adherence to relevant labor laws, ethical sourcing of materials, and ensuring product safety are integral to a holistic approach to sustainability that aligns with the spirit of ISO 14006-2020 by promoting responsible environmental stewardship that considers human impact. The standard encourages a life cycle perspective, which naturally extends to evaluating social impacts alongside environmental ones. Therefore, considering the ethical sourcing of raw materials and ensuring fair labor practices throughout the supply chain are crucial elements that complement the environmental objectives of ecodesign as guided by ISO 14006-2020. Question 23. Consider a manufacturing firm in the United Kingdom that is designing a new line of industrial pumps intended for distribution across the European Union. To ensure seamless market access and adherence to environmental mandates, what is the most effective ecodesign strategy for integrating legal compliance requirements into the product development lifecycle, as guided by ISO 14006-2020? Option A. Primarily focusing on the end-of-life management of the pumps, ensuring they meet recycling targets stipulated by WE directives, and addressing other legal aspects as they arise during manufacturing. Option B. Relying on external consultants to perform a post-design legal review of the industrial pumps to identify any potential non-compliance issues before market launch. Option C. Concentrating solely on reducing the energy consumption of the pumps during their operational phase, as this is the primary focus of many EU environmental regulations, and deferring other compliance aspects to later stages. Option D. Proactively identifying all relevant EU environmental regulations, such as the ecodesign directive for energy-related products and specific substance restrictions, and embedding compliance checks into each design and development stage. The correct answer is D. Proactively identifying all relevant EU environmental regulations, such as the ecodesign directive for energy-related products and specific substance restrictions, and embedding compliance checks into each design and development stage. Explanation: ISO 14006-2020 emphasizes integrating environmental considerations into product development, which includes understanding and complying with relevant legislation. When a company is developing a new electronic device for the European market, it must consider directives such as the Restriction of Hazardous Substances, RoHS, directive, and the Waste Electrical and Electronic Equipment, WE directive. RoHS restricts the use of specific hazardous materials in electrical and electronic equipment, while WE sets requirements for the collection, recycling, and recovery of electronic waste. Incorporating ecodesign principles means proactively identifying and managing these legal requirements during the design phase to avoid noncompliance and associated penalties. This proactive approach aligns with the lifecycle perspective encouraged by ISO 14006, ensuring that environmental impacts, including those stemming from regulatory obligations, are considered from raw material extraction through end-of-life management. Therefore, the most effective strategy for ensuring legal compliance within an ecodesign framework involves a thorough understanding of applicable environmental regulations and their integration into the design process from the outset. This proactive identification and integration are crucial for meeting market access requirements and demonstrating environmental responsibility. Question 24. Consider an advanced electronics manufacturer aiming to enhance the end-of-life management of their complex audio equipment according to ISO 14006-2020 guidelines. The design team is evaluating different strategies to improve the ease with which components can be separated and recovered. Which of the following design considerations most directly aligns with the core principles of design for disassembly for improved material recovery and reduced environmental impact? Option A. Integrating components directly into the main chassis through ultrasonic welding, thereby eliminating visible fasteners and creating a sleek aesthetic. Option B. Maximizing the density of electronic components to reduce the overall product size, irrespective of their accessibility or the joining methods used. Option C. Utilizing snap-fit connectors that require specialized tools for release, combined with a broad range of composite materials for structural integrity. Option D. Employing a modular design where key components are secured with standard, easily removable fasteners and are clearly labeled for material identification. The correct answer is C. Utilizing snap-fit connectors that require specialized tools for release, combined with a broad range of composite materials for structural integrity. Explanation: the principle of design for disassembly, DFD, under ISO 14006-2020 focuses on making products easier to take apart at the end of their life cycle. This facilitates the recovery of materials and components for reuse or recycling, thereby reducing waste and the need for virgin resources. A key aspect of DFD is the selection of joining methods and materials. For instance, using mechanical fasteners like screws that can be easily removed with standard tools is preferable to permanent bonding methods such as adhesives or welding, which often require destructive processes to separate. Material selection also plays a crucial role. Using homogeneous materials or clearly marking composite materials aids in sorting and reprocessing. Furthermore, the arrangement and accessibility of components are critical. If components that are frequently replaced or contain hazardous substances are difficult to access, it impedes efficient repair and end-of-life processing. Therefore, a design that prioritizes ease of separation through appropriate fastening, material choice, and component layout directly supports the environmental objectives of ecodesign, particularly in the context of circular economy principles and waste hierarchy promotion, as advocated by ISO 14006-2020. This approach minimizes the environmental burden associated with product disposal and maximizes resource value retention. Question 25. A manufacturing firm aiming to enhance its environmental performance in line with ISO 14006-2020 is developing a new line of portable consumer electronics. They are particularly focused on creating innovative solutions that address potential end-of-life challenges and resource depletion. Considering the guidelines for incorporating ecodesign, which of the following strategies would most effectively foster the creation of novel, environmentally superior product designs within their existing management system? Option A. Implementing a mandatory 5% reduction in material usage across all new product lines, enforced through strict engineering specifications and supplier audits. Option B. Focusing solely on energy efficiency improvements during the product's use phase, as this is often a significant contributor to the overall environmental footprint. Option C. Conducting a one-time environmental impact assessment for the initial product prototype and using the results to justify minor material substitutions. Option D. Establishing a cross-departmental ecodesign task force with representatives from R&D, manufacturing, marketing, and procurement to systematically identify and evaluate life cycle impacts and brainstorm innovative solutions. The correct answer is D. Establishing a cross-departmental ecodesign task force with representatives from R&D, manufacturing, marketing, and procurement to systematically identify and evaluate life cycle impacts and brainstorm innovative solutions. Explanation: ISO 14006-2020 emphasizes the integration of environmental considerations into product development, promoting ecodesign principles. Creating innovative solutions within this framework involves a proactive and systematic approach that goes beyond mere compliance with regulations like the Waste Framework Directive or REACH. It necessitates understanding the entire life cycle of a product, from raw material extraction to end-of-life management, and identifying opportunities for environmental improvement at each stage. This often involves cross-functional collaboration, engaging diverse perspectives to brainstorm novel approaches. For instance, a company developing a new electronic device might explore modular design to facilitate repair and upgrades, use recycled or bio-based materials, optimize energy efficiency during use, and design for easier disassembly and material recovery at the end of its life. This holistic view, coupled with a commitment to continuous improvement and stakeholder engagement, is key to generating truly innovative and environmentally sound solutions that align with the spirit and requirements of ISO 14006-2020. The process involves anticipating future environmental challenges and regulatory shifts, fostering a culture of innovation that embeds sustainability into the core of product design and development. Question 26. Considering the principles outlined in ISO 14006-2020 for incorporating ecodesign, which criterion would be most indicative of a supplier's commitment to upstream environmental impact reduction when selecting them for the provision of specialized electronic components? Option A. The supplier consistently meets all mandatory national environmental discharge limits for wastewater and air emissions as reported in their annual compliance statements. Option B. The supplier has a comprehensive corporate social responsibility report that includes general statements about sustainability without specific environmental performance targets. Option C. The supplier's documented environmental policy explicitly addresses the reduction of energy consumption and waste generation in their manufacturing processes and includes provisions for sourcing materials with higher recycled content. Option D. The supplier offers the lowest unit cost for the electronic components, with a minimal mention of their environmental management practices in their marketing materials. The correct answer is C. The supplier's documented environmental policy explicitly addresses the reduction of energy consumption and waste generation in their manufacturing processes and includes provisions for sourcing materials with higher recycled content. Explanation: ISO 14006-2020 emphasizes the integration of ecodesign principles throughout the product lifecycle, including the selection of suppliers. When evaluating potential suppliers for raw materials or components, an organization committed to ecodesign, as guided by ISO 14006-2020, would prioritize those who can demonstrate a proactive approach to minimizing environmental impacts at their own operational stages and in their own supply chains. This involves looking beyond mere compliance with environmental regulations, such as those concerning waste management or emissions, e.g., the EU's Waste Framework Directive or national air quality standards. Instead, the focus shifts to suppliers who actively implement environmental management systems, possess certifications like ISO 14001, and can provide data or evidence of their efforts in areas such as resource efficiency, the use of recycled content, reduced energy consumption in manufacturing, and the minimization of hazardous substances in their production processes. The goal is to ensure that the upstream environmental burdens associated with the procured materials or components are as low as possible, thereby contributing to the overall ecodesign objectives of the final product. This proactive stance, often evidenced by a supplier's environmental policy, performance metrics, and willingness to collaborate on ecodesign improvements, is a key differentiator for an environmentally responsible supply chain. Question 27. Consider a multinational electronics manufacturer aiming to integrate ISO 14006-2020 guidelines for ecodesign into its product development lifecycle, specifically for a new line of smart televisions. Given the increasing global regulatory focus on energy efficiency, such as the EU's ecodesign directive, which mandates specific performance criteria for energy-related products, what is the most critical ecodesign consideration that the manufacturer must prioritize to align with both the standards principles and relevant external requirements for this product category? Option A. Minimizing the use of rare earth elements in the display technology. Option B. Implementing a robust take-back program for end-of-life product recycling. Option C. Reducing energy intensity and waste generation during the manufacturing process. Option D. Optimizing energy consumption during the product's operational use phase. Correct answer is D. Optimizing energy consumption during the product's operational use phase. Explanation. The question asks about the primary consideration for incorporating ecodesign requirements into energy-related products within an ISO 14006-2020 framework. ISO 14006-2020 emphasizes a life cycle perspective for environmental management and ecodesign. For energy-related products, the most significant environmental impacts often occur during their use phase, primarily due to energy consumption. Regulations like the EU's ecodesign directive, Directive 2009/125/EC, and its implementing measures specifically target improving the energy efficiency of products during use. Therefore, while material selection, end-of-life management, and manufacturing processes are important aspects of ecodesign, the direct and substantial environmental burden associated with energy consumption during product operation makes it the paramount consideration for energy-related products under ISO 14006-2020. This aligns with the directive's focus on reducing energy consumption and related emissions throughout the product's life cycle. The standard encourages a holistic approach, but for energy-related products, the use phase impact is typically the most critical driver for ecodesign improvements. Question 28. Considering the evolving landscape of environmental legislation and consumer demand for sustainable products, which strategy best exemplifies the proactive integration of ecodesign principles within an ISO 14006-2020 compliant environmental management system, anticipating future regulatory shifts and market expectations? Option A. Relying on external consultants to inform the organization about upcoming environmental legislation only after it has been officially published and enacted. Option B. Implementing ecodesign measures solely in response to customer complaints regarding the environmental performance of existing products, without a systematic forward-looking approach. Option C. Primarily focusing on meeting existing mandatory environmental compliance standards for current product lines, with minimal investment in research for future-oriented design changes. Option D. Proactively identifying and incorporating potential future restrictions on material use and end-of-life management requirements into current product design specifications, based on trend analysis of international environmental regulations and circular economy principles. The correct answer is D. Proactively identifying and incorporating potential future restrictions on material use and end-of-life management requirements into current product design specifications, based on trend analysis of international environmental regulations and circular economy principles. Explanation. the core principle of incorporating ecodesign into an environmental management system, as guided by ISO 14006-2020, involves a systematic approach to integrating environmental consideration throughout the product lifecycle. This integration aims to reduce environmental impacts from the earliest stages of conceptualization and design through to end-of-life management. A key aspect of this is foresight, anticipating future environmental regulations and societal expectations. For instance, anticipating stricter controls on certain chemicals or the need for enhanced recyclability, as mandated by evolving directives like the EU's ecodesign directive, which is often updated and influences global trends, allows organizations to proactively adapt their product development processes. This proactive stance is more effective and less costly than reactive changes made after regulations are enforced. Therefore, a forward-looking approach that considers emerging environmental challenges and potential legislative changes is crucial for successful ecodesign implementation within an EMS. This proactive adaptation is a hallmark of a mature environmental management system aiming for continuous improvement and long-term sustainability, aligning with the spirit of ISO 14006-2020 in fostering a life cycle perspective. Question 29. An electronics manufacturer adhering to ISO 14006-2020 is redesigning the packaging for its portable devices. They are specifically looking to align their ecodesign strategy for this packaging with the objectives of the EU's Packaging and Packaging Waste Directive, PPWD. Which of the following ecodesign considerations for the new packaging would most effectively contribute to meeting the PPWD overarching goals of waste prevention and circularity, while also reflecting the integrated approach of ISO 14006? Option A. Developing a reusable packaging system that requires a deposit refund scheme for consumers, without considering the energy and resource implications of the return and cleaning logistics. Option B. Incorporating a significant proportion of recycled content into the packaging, without a primary focus on the packaging's end-of-life disassembly or overall material reduction. Option C. Utilizing a single, high-density polyethylene, HDPE material for the entire packaging, as HDPE is a widely recycled plastic, even if it increases the overall material weight. Option D. Designing the packaging to be easily disassembled into monomaterials for enhanced recyclability, while also minimizing the overall weight and volume of the packaging to reduce transport emissions and material consumption. The correct answer is D. Designing the packaging to be easily disassembled into monomaterials for enhanced recyclability, while also minimizing the overall weight and volume of the packaging to reduce transport emissions and material consumption. Explanation: ISO 14006-2020 emphasizes the integration of ecodesign principles throughout the product lifecycle. When considering packaging waste, specifically in the context of the EU's Packaging and Packaging Waste Directive, PPWD, the focus is on minimizing environmental impact from production to end of life. The directive sets targets for recycling, recovery, and reduction of packaging waste. Incorporating ecodesign, as guided by ISO 14006, means proactively designing packaging to meet these regulatory requirements and broader sustainability goals. This involves considering material selection for recyclability and reusability, minimizing material content, optimizing design for efficient transport to reduce emissions, and ensuring ease of separation of materials at the end of life. A key aspect is aligning the packaging's environmental performance with the overall environmental management system of the organization, ensuring that the ecodesign choices contribute to achieving the organization's environmental objectives and targets, including those related to waste reduction and resource efficiency, as mandated by regulations like the PPWD. The directive's emphasis on producer responsibility and the circular economy principles directly informs ecodesign strategies for packaging, aiming to prevent waste generation and promote sustainable material flows. Question 30. Consider a hypothetical scenario involving an aerospace company developing a new advanced composite material. This material requires significant energy input for its high-temperature curing process and incorporates rare earth elements in its matrix for enhanced performance. During its operational life, the material is durable but difficult to repair, and at its end of life, it presents significant challenges for conventional recycling due to its complex chemical structure. Which of the following best encapsulates the primary environmental aspects and impacts that the company should prioritize for ecodesign integration, in alignment with ISO 14006-2020 principles? Option A. The biodegradability of the material in natural environments and the potential for its use in consumer electronics. Option B. The aesthetic appeal of the composite and the ease of its installation by end users. Option C. The cost-effectiveness of the raw materials and the noise generated during the manufacturing process. Option D. Energy consumption during curing, resource depletion of rare earth elements, and end-of-life disposal challenges related to material complexity. The correct answer is D. Energy consumption during curing, resource depletion of rare earth elements, and end-of-life disposal challenges related to material complexity. Explanation: ISO 14006-2020 emphasizes a life cycle perspective for ecodesign. When considering the environmental aspects and impacts of a product, a comprehensive approach is crucial. This involves identifying potential environmental burdens at each stage of the product's life, from raw material extraction and manufacturing to use and end of life. For a hypothetical advanced composite material used in aerospace, key environmental aspects would include energy consumption during high-temperature curing, potential release of volatile organic compounds, VOC, during manufacturing, resource depletion associated with rare earth elements in some formulations, and challenges in recycling or safe disposal due to the material's complex structure. The corresponding environmental impacts could include greenhouse gas emissions from energy use, air pollution from VOCs, habitat disruption from mining, and potential landfill contamination or inefficient resource recovery at end of life. ISO 14006-2020 guides organizations to integrate these considerations into their environmental management systems and product design processes, aiming to prevent or minimize environmental burdens throughout the product's life cycle. This proactive approach aligns with regulatory drivers like the EU's ecodesign directive and waste framework directive, which promote circular economy principles and sustainable product design. Therefore, the most encompassing and accurate representation of these considerations for such a material would focus on the entire life cycle, encompassing both the direct and indirect environmental consequences.